Welcome back to the Deep Dive, and today, a special one under our BodyTalks banner. We are exploring a scientific phenomenon that's become, well, a cultural earthquake.
That's a good way to put it.
The class of drugs known as GLP-1 agonists. You probably know them as Ozempic or Wegovy.
Right.
And this isn't just about weight loss stats. This is about a biological revolution that's forcing us to, discard some really old moralizing assumptions about willpower and metabolism.
That is the core mission for us today. Our sources reveal two fundamental, almost counterintuitive truths about these drugs.
Okay.
First, we're going to get into this astonishing origin story. It takes us deep into the desert with a venomous lizard.
A venomous lizard, love it. And second,
we're going to define the concept of food noise, which just fundamentally explains the patient experience. It proves the struggle with food is often biology, not, a lack of personal resolve.
And the timing on this is perfect because the cultural visibility is just massive.
Oh, it's everywhere.
We're talking about a drug class endorsed by tech titans like Elon Musk. He's argued that making these GLP-1 inhibitors low-cost and accessible would do more for American health and lifespan than almost anything else.
And that's where the irony really kicks in.
Right.
We're talking about this massive medical revolution, but the very foundation for it, the science that allowed this drug class to even exist, came directly from basic government-funded research.
At the National Institutes of Health?
Exactly. The very type of curiosity-driven science that figures like Musk sometimes target for funding cuts because it doesn't have an immediate, obvious commercial payoff.
So we have this huge political and economic paradox wrapped around a tiny molecule. Before we get to the lizard, let's just quickly define that mechanism. You mentioned GLP-1. What is it?
So GLP-1 stands for glucagon-like peptide 1. It's a hormone, an incretin hormone, that our own gut produces naturally.
Right.
Its job is complex, but it basically does two main things. It tells the pancreas to release insulin when you eat, which regulates blood sugar.
Right, for diabetes.
And crucially, it also acts on the brain to signal satiety, that feeling of being full, and it slows down how quickly your stomach empties.
Got it. So food stays in your stomach longer, you feel fuller, longer.
Right.
A natural appetite regulator?
Precisely. But the human version is too fragile to work as a drug.
Which brings us to the science that solved that problem. And it really does start in a lab, about 40 years ago.
We have to go back to the early 1980s to a young gastroenterologist named Jean-Pierre Rothman. He was just starting his work at the NIH.
An era where you could just explore.
You could, and Rothman wasn't hunting for a diabetes cure. He was just hunting for knowledge.
And the documents describe this as pure grunt work. His supervisor wanted to know if animal venoms, the nastiest stuff on the planet, could trigger the pancreas to release digestive enzymes.
It was a total scientific fishing expedition. That's the perfect term for it. He spent weeks just dissolving powdered venom into water.
From what?
You name it. Bees, wasps, snakes, frogs, lizards. And then he'd test that solution on tiny samples of guinea pig pancreas. As Rothman himself said, it wasn't glamorous. You could work all day and get, absolutely zero reaction. You had to have a real devotion to stick with it.
But that devotion paid off. In one instance, spectacularly. So after all that testing, which venom gave the single biggest, most dramatic reaction?
The Gila monster.
The Gila moths.
Yeah, Heliderma suspectum. It's this large, really strikingly patterned orange and black venomous lizard, native to the southwestern U.S. and Mexico.
And what was the initial reaction? Did he jump up and yell, "We've cured diabetes"?
Not at all. His reaction was pure academic curiosity. He and his colleagues published their findings, and they just called it an interesting biological finding.
That's it?
That's it. In fact, Rothman later recalled, and I'm quoting here, that he would never have conceived that there was any potential therapeutic benefit for anything. It was just pure, basic research.
Which sets up the critical question. How does an interesting finding from a lizard become a multi-billion-dollar solution for metabolic disease?
The breakthrough came when Rothman and a colleague finally isolated the specific protein in the venom that was causing that reaction.
Okay.
And they discovered that this protein was a near-perfect mimic of the human GLP-1 hormone we just talked about.
But why did they need the lizard version if we have our own?
Stability. That was the key. Researchers like an endocrinologist named Daniel Drucker in Toronto, they knew about GLP-1, but the human version gets broken down by our enzymes almost instantly.
So it's useless as a drug?
Totally useless. You inject it, it's gone in minutes. But the Gila monster had evolved a version, they called it Exendin 4, that was incredibly resistant to breakdown. It could last for hours.
So the lizard's venom was the blueprint for a stable, long-acting drug. And Drucker, this researcher in Toronto, he hears about Rothman's discovery.
He does, and the steps he took next are well, they're incredible.
What did he do?
He needed to study the protein, so he shipped a live Gila monster to Canada.
Wait, a live one?
A live Gila monster. Imagine that. A researcher in Toronto focused on diabetes, and his solution requires studying the genes of this huge, venomous lizard shipped up from the desert.
That kind of focus is what gets things done.
It is, and it led directly to the FDA approving the first GLP-1 therapy for diabetes in 2005.
Now, this is where it gets really interesting, because we have to talk about the unexpected benefits. If the goal was just treating diabetes, why did it become this blockbuster weight loss drug?
Because they didn't know the full extent of what it could do.
Really?
Really, once this stable lizard-derived protein went into human trials, its effects on the brain and the gut were just profound. Researchers like Drucker admit they didn't know the drug would reduce appetite so effectively.
Or that it would lead to massive reductions in heart attacks and strokes.
Or that it would improve metabolic liver disease. These were all essentially fortunate side effects of fundamental, curiosity-driven research.
Which makes Rothman's concerns about funding today feel almost painful. If the NIH now requires you to prove up front that your work will lead to a cure, could a fishing expedition like testing lizard venom even happen?
Rothman is pessimistic about it. He argues the high bar for grants today would almost certainly classify his original work as, too speculative. A fishing expedition.
And there's the heart of the irony. A drug that improves health on so many fronts might never have been created under today's funding rules.
Exactly. It's a frustrating reality.
And that frustration leads us directly from the lab to the patient. Let's pivot now from the molecule to the mind and what this drug actually feels like.
We need to transition from the biology of the drug to the biology of the brain. And the concept that just perfectly defines the patient experience here is food noise.
I found the anecdotes in the source material so relatable.
Mm-hmm.
This feeling of being an intelligent adult who knows they shouldn't eat something, but you feel completely preoccupied, almost pulled by some metaphysical tide toward that bag of chips, that constant mental battle.
That is exactly it. A doctoral researcher at Penn State, Daisuke Hayashi, he studied this. He defines food noise as the persistent, intrusive thoughts about food and eating between mealtimes.
It's more than just being hungry.
Oh, far more. It's a constant, demanding mental chatter that just governs your daily life.
So when you look at patient reports from before they start the medication, how serious is this internal monologue?
It's debilitating. When the volume is high, food noise becomes, and I'm quoting, constant and obsessive thoughts that detract from a person's well-being.
It sounds exhausting.
It is. We're talking about thoughts that hijack your concentration, they influence your mood, they make any food environment a source of anxiety. It is consistently described as a profound source of suffering.
So it's that intrusive? Where does it come from? Is it just a lack of self-control?
No, absolutely not. It's a response to something deeper. Food noise is an intense reaction to what we call food cues.
Cues like what?
They can be external, the social media ads, the smell from a bakery, the candy at the checkout stand, but they're also internal, stemming from those very appetite-regulating hormones we talked about.
So we're being bombarded by these cues from the outside, and our internal biology is already maybe running hot.
Precisely. This heightened response is likely caused by a cocktail of factors. Genetics, stress, and critically, the modern world we live in.
The food environment.
Our world is specifically designed to constantly expose us to powerful external food cues. It ensures we're always thinking about eating, even when we don't physically need to.
Which brings us full circle. If food noise is the problem, how exactly does the Gila monster's legacy, the GLP-1 drug, solve it?
Hayashi's hypothesis is that one of the drug's most powerful effects is changing the brain's response to those cues.
So it's not just filling your stomach.
It's not. It's making people less responsive to the cues themselves. It's literally turning down the volume on that psychological demand. That obsessive mental chatter it quiets down. And that frees up a massive amount of mental energy.
That is such a vital distinction. It shifts the entire narrative away from this outdated, punitive idea of a personal failing. It's a biological correction, not a moral one.
We can't overstate how important that is. Avoiding the guilt trap, Hayashi points out the paradox we live in.
Which is?
We are saturated with messages glorifying extreme thinness and health while living in environments that actively encourage high-calorie processed food consumption.
Environments engineered to be irresistible. highly palatable, energy-dense foods available everywhere, 247.
It is a perfect storm. When you combine our internal biology with an environment designed to constantly expose us to food cues, you have, quote, a perfect formula for struggling with food noise. Acknowledging that is key.
That has to be so liberating for people to hear, to know it isn't just a failure of willpower. But what about strategies for people who aren't on these medications?
Well, the research on intrusive thoughts still offers some non-pharmaceutical strategies.
Like what?
Hayashi suggests working with a dietitian to identify your personal patterns and triggers. Also, things like practicing slow, mindful eating to better register satiety signals. Or just ensuring your meals are substantial enough to prevent those intense hunger pangs that amplify the food noise.
So let's synthesize this. We started with a scientist in the 1980s, Jean-Pierre Rothman, testing lizard venom on a guinea pig organ.
A project he never thought would have any therapeutic potential.
And that seemingly random foundational research led us, decades later, to a medication that treats complex metabolic diseases.
And it does so by essentially silencing the relentless, obsessive psychological experience of food noise. It successfully moves the conversation from a moral challenge to a biological one.
So here is the final provocative thought for you to explore. The story of GLP-1s, from a desert lizard to a global health phenomenon. It illustrates a powerful lesson. The most profound therapeutic breakthroughs, the ones that reduce heart attacks, revolutionize obesity treatment, they often originate not from targeted attempts to cure a specific disease,
but from simple, publicly funded scientific curiosity about how the world works. It reminds us that we should never underestimate the long-term value of basic scientific exploration, even if it seems like a tedious fishing expedition at the time.
Absolutely fantastic insight. Thank you for joining us for this Body Talks Deep Dive. We encourage you to subscribe to the Deep Dive and please leave a comment with your thoughts on the value of curiosity-driven research. We'll see you next time.